Hi, and welcome to part 1 of my How to Robots series. I'm Joe, and I'm taking this series very seriously. I've cleaned my desk. I've cleaned this part of my desk just for it. Now, laid out in front of me, I have all of the electronics parts that we're going to need. The brain of the system will be an Arduino Uno revision 3. There is a revision 4 out. It probably will work exactly the same, but I haven't used one yet, so I can't guarantee it. This one is very common and easy to get. This particular one is a knockoff made by Elegoo and cost me $18 US. Next we have the legs. That would be wheels. This was a 4-pack of wheels I got for about $10 US. They're obviously not the Cadillac of motors and wheels, but I think they'll do the trick just fine. Now, when looking for these, the thing you want to look for is a motor that's meant for 3 to 6 volts. Amazon seems to be full of them. I'm going with Amazon for all the parts supply because you can get stuff from Amazon most anywhere. To control those motors, we're using this L298N based motor control board. This board can control 2 different motors, which makes it perfect for our application because we have 2 motors. It's easy to use. There seem to be many suppliers of it on Amazon. Search it up, and really, if it looks right, it probably is right, because they look all the same, and every board that I've ever gotten has been the same. To power it all, we're going to be using a AA battery clip that holds 4 AA's. That will give us 6 volts to power everything. Just as a heads up, I recommend using disposable AA batteries, because they have a slightly higher voltage than the rechargeable AA batteries. And we need that voltage to make the Arduino work properly. Future Joe here. Actually get 2 of these battery clips. We're going to be using one to power the Arduino and one to power the motors. I got the robot together, and spoiler, I had a little trouble with the Arduino resetting because the motors would cause voltage spikes. Next we have some micro snap switches, or limit switches, whatever you want to call them. You can search for micro switch, you can search for limit switch. If it looks like this, it'll be about the right thing. They make different sizes of these, but that's alright. These will be our first touch sensors. They will be the bumpers, so the robot knows if it hit something that it ran into. That wasn't worded well. If it hit something. And we'll need some wire. This project is supposed to be one that you can do without any specific electrical tools. So if you get these wires, they have a little connector on each end. And they make different varieties. They have ones with a socket on one end and a pin on the other, or a socket on both ends, or a pin on both ends. These are very handy little wires to have. And now for the arts and crafts side of things. Okay, now for the chassis, I've got more supplies right in front of me than I actually need. But all we really need is a flat plate that we can attach everything to. So, I will be using popsicle sticks, or tongue depressors. My mom's in the medical industry, and so that's what she calls them. Yeah, these are from a craft store. However, the chassis could also be made from a foam meat tray, which is very common, at least here in the US. I'm going to be using the popsicle sticks because they are a bit more robust. And I will be attaching them all together. In fact, I'll be even attaching some of these components to this board with hot glue. Now just keep in mind that this glue gun is hot. Try not to burn yourself. And put on clothes that you don't mind getting destroyed. No, that's paint. If you're getting hot glue all over yourself, you're doing it wrong. We will need a way to cut things. I have scissors. Don't use mom's sewing scissors. I have glue sticks for the glue gun, and that's it, save for a secret component that I will reveal at the end of the video to give you maximum satisfaction out of this robot. Well, let's get building. I am going to use these somewhat larger popsicle sticks just because they seem like the right thing to use. I'm just going to pull out a few of these. And I will make my robot with a square chassis. I think that will do it. So that would be a good size for the chassis, but let's find out if it's going to fit everything. It needs a battery pack and a motor controller and our Arduino. Let's open that up right now. Now the Arduino itself comes with an anti-static bag. You can remove it from the bag, but try to only touch it by the edges of the board or by the connector. Try not to touch the pins. If those get zapped with static electricity, you'd have a dead Arduino. You know what? We will have enough room. This will be just fine. Oh no, we're gonna have a gap there. Well, that could bug me. I'll try and... Ooh, actually, I can make use of that gap. It's not perfectly square, but it'll do a trick. Time to get out these little beauties. The motors and wheels. We only need 2 of them. There we go. Motors and wheels. We only need 2 of them. In this particular kit, it looks like the wheel just presses onto the motor. Voila. I like it. These will get glued to the bottom of the chassis. I've decided this side's the bottom. Just glue the side of the motor right onto that popsicle stick there with hot glue. The hot glue will do a fairly good job of holding it, I think. I'm pretty sure anyway. I just really like my glue gun. Yes. Okay, I really have no business filming with one hand while working with the other. I can't do that. I apologize. It's crooked. Make it straight. There we go. Now this can sit up right. Now I've forgotten a piece that I need. We need some sort of a thing here. A little front wheel or slide. Could be anything that's smooth enough to slide along whatever surface this thing's rolling on. I'll be right back. Here we go. I'm going to use a water bottle cap. Make the cut about there. Damn it! Trim this up. Oh no, the hot glue is shrinking the plastic. But it sits and fits. Hot glue strings. Now I'm going to take advantage of these slots by putting the motor wires through it. Helps keep it clean and nice and intentional looking. Alright, let's see how these things lay out now. The battery pack I'm going to put back here for the weight. The motor controller also makes sense back there, but I want to keep it balanced, left to right, so I don't get more traction on one side. So I'll probably arrange it like that. Let's see, do these motor wires reach? Just barely, but they will. We're getting places. These little snap switches are going to be our bumpers. Isn't that a lovely sound? But we need some whiskers on them. Make them longer. Since I have them, I'm going to use the smaller popsicle sticks for that. Excuse me, wooden craft sticks. I always grew up calling them popsicle sticks because, well, I mean, that's how I got them when I was a kid. You'd eat a popsicle, you got a stick. I saved the sticks because I like to put hot glue on them. Now, this little snap switch lever is metal. Hot glue doesn't always stick well to metal, so I'm going to glue it down and put some glue on the back of it to capture it like a sleeve. I like that. Alright, now it's time to attach some of the circuit boards to the chassis. Now, I don't really want to glue them down, so I've come up with a solution. My camera's pretty bad at focusing close up, so I apologize for any blur you get. But these circuit boards here have nice big mounting holes in them. So what I'm going to do is cut the Q-tips to make posts that will be glued down, and the circuit board will slide over them. Let me pre-mark these holes. I'll post there, and there, and there, there, post there, and there, and there, and there. That one, you know. Look at that. Mounted and removable. So before we move on with gluing things down, we need to do some wiring. For this I'm going to be using the wires with pins on both ends. They're a bit longer than I need, but this is what I've got, so we're using it. So first, our power wires. I will use, just peel these off, red and black. Black will be 0 volts, or ground, and red will be 5 volts. Now I'm going to strip back a bit of the insulation on this wire here. We need a little bit more copper exposed. Now I'm going to try and do this with scissors. It's way easier with the proper tools. If you have wire strippers, please use them. But, you know, you can do this with just scissors. However, I can't film with one hand and do wire stripping with the other. So I'm going to be biting down on the wire and try to do it so that it's not hard enough to cut through the wire. And then I will pull outward like this and pull that wire insulation off. Bite down and pull. And I've done that on the other one as well. Future Joe here again. This is where you ignore the fact that you see one battery clip on the robot and imagine that there are two. The two battery clips will be arranged side by side like this on the back of the robot. One will be wired to the Arduino and the other wired to the motor controller. We're going to take the two black wires here and twist them together as one. I can't really do that one-handed, so I'm going to have to put down my camera I have in my hand right now. Now these will be wrapped around the pin of the black wire that will go to the Arduino. This is the common ground for the entire robot. And these wires get inserted into the ground pin of the terminal block on the motor controller. Now when you look at the bottom of the board, at least on this one, and hopefully with any one that you get, the pins are very nicely marked on the bottom. We have here 5 volts, ground, and 12 volts. Now, except for ground, those other two are kind of suggestions. They have different meanings. We'll get deeper into that at a different time. For right now, the pins we're going to be using are ground, G and D, and plus 12 volts, which we're going to be feeding at 6 volts. It'll be all right. Those numbers are guidelines, more like. The 5 volt pin is an output, so if you give it 12 volts in, this board will produce 5 volts out from the 5 volt pin. But we won't be using that feature. You'll need a small screwdriver. These terminal blocks, some of them are very nice. Some of them are really awful to use. These ones are more on the awful side of the spectrum. Put that one in. Black, negative, is ground. Slide that in and tighten down the screw. Make sure they're nice and tight. Good. Next, we take the positive wire from the motor battery pack and insert it into the terminal block 12-volt post. These terminal blocks have trouble gripping the very small wire, so fold it in half. That'll help. Now the positive wire from the second battery case will be twisted around the pin of that red wire that is used to power the Arduino itself. And for safety, we're going to put a little bit of tape around that connection to make sure it can't touch anything else. This one-handed work is very hard to do. Very ugly, but that'll do the trick. Alright, now we'll hook up the motors. Now I don't know which way is forward or backward yet, so I'm going to hook up these wires arbitrarily, and if there's any reversing problems, we'll fix that in other places. So I will find the two wires from the left motor, and I'm going to put them in this front side of the board into the 2-pin header. Positive and negative. And tighten these down. Now I will do the same for the two wires from the left motor. Right motor. Positive into this terminal block and negative right beside it. And I will route these wires nicely kind of underneath the board and slide it back down on its indexing pins. Alright, and there it is. These are the left motor wires. These are the right motor wires. And here is your ground and power. Now, the inputs that control this motor controller are these 4 pins right here. They are labeled N1, N2, N3, and N4. Now, 2 of these pins correspond to forward on the 2 motors, and 2 pins correspond to reverse on the 2 motors. Now we need to map which ones those are. For this, I'm going to use these wires with the pin on one end and the socket on the other. I just need one of them. I'm going to peel it off. And I will place this wire on N1. Now it's time to load in some batteries. Put this 4th battery in, and we have an LED that came on the motor controller. Good. So if I take this wire we just hooked up to N1 and touch it here to the positive terminal, that is going to give it an on signal, a 1, and we'll see which motor goes which direction. Aha! That makes the right motor go forward. N2, let's test that one. I've moved the wire to the next pin, N2, and now I will touch it to the positive lug. And that makes the right motor go backward. Now I have N3, and I will touch this to the positive lug. N3 makes the left motor go backward. And now N4, and if I touch this to the positive, the left motor goes forward. So going in order of 1, 2, 3, 4, the pins are right forward, right reverse, left forward. Now I like to write those things down on a sticky note, stick them on my screen, something like that. I have it on video in this case, so I don't have to write it down. But it might help you if you write it down on yours, because these cheap little drive motors, there's no guarantee which way is actually going to be forward and actually going to be backward when you plug them in. So doing this test will give you your answer and make programming way easier. I will now remove the battery, at least one of them. To break the circuit, now it's off again, and I can continue with wiring this. Now it's time to hook up the motor controller to the Arduino. I'll be using those same short wires with the pin on one end and the socket on the other. And they are plugged in to pins 1, 2, 3, and 4 on the motor controller. Pretty as a picture. Now on the Arduino, all of the pins are very nicely labeled. some of these pins have this little tilde symbol, the squiggly line in front of it. That means it's a PWM pin, which is a motor control thing. We will cover that later, but for right now, well, we won't go into it, but we are going to be using those pins with the tilde. I am going to be attaching in 1 from the motor control board, pin 3, in 2 to pin 5, in 3 to pin 6, and in 4 to pin 9. These are all the PWM capable pins. This will allow us to have variable speed of our motor controller. Later on, our first version we're just going to do on and off. Now over here on the other side of the Arduino we also have nicely labeled pins. The ones that we are concerned with at the moment are the ones labeled G and D, which is ground, or 0 volts. Ground is usually used to mean 0 volts in electronics. There are exceptions, but they are rare. So this ground wire from our motor control board, that one goes to ground pin of the Arduino. Now the red wire that is coming from our positive, our 6 volts from the battery pack, will go into the V-in pin right beside the ground. That's where we're going to leave off this week. Mostly because I ran out of time for editing. This is my first how-to video I've done, and I grossly underestimated how much recording and editing it would actually take. So it's become very long. Please bear with me. Next time we're going to be wiring up the bump sensors, then installing the Arduino software on your computer so that you can program the device, and we'll begin programming it. I'm going to try to break down the programming process as much as I've broken down the assembly process of the robot. Get every detail so that you can understand exactly everything that's gone on. So with that, please like and subscribe if you want to see the next video. Leave a comment, tell me how I'm doing at this whole how-to video thing. This is the first time I've done it, and feedback would be very valuable. I really want to do a good job at teaching. So until next time, this is Joe, signing off. Now I promised a secret construction material at the end. So, here it is. Googly eyes.